and video series, and today's topic is hypothesis testing. In business, there are so many decisions has to be made every day. Instead of making them by hunch, doing experiments and creating hypotheses is more data-centric approach of taking decisions in business. Hypothesis testing is a mechanism for taking decisions in inferential statistics. Hypothesis testing also provides a structure for solving a particular problem. Statistical hypothesis comes into a picture when a researcher already has an idea about the outcome, even before doing the experiment. The statistical hypothesis provides a standard structural framework to work on the problem and make a decision-centered decision. Statistical hypothesis consists of two parts. First, null hypothesis, and second, alternative hypothesis. The null hypothesis states the null condition exists, meaning the statement that has been said is happening and nothing new is expected. The alternative hypothesis is the new theory is true or something new is happening. So this is how these two parts are defined. To understand the statistical hypothesis and the two parts of it, that is null hypothesis and alternative hypothesis, let's consider two examples. First example, during a census operation, the official wanted to confirm the average height of the country people has changed or still the same. So for example, let's say the average height that has been so far calculated was 160 centimeter. Now the official wanted to confirm whether it has changed over the period of time or it is still the same. For this particular purpose, if we employ a statistical analysis here or hypothesis testing, we have to define the two parts. First is null hypothesis and the second is the alternative hypothesis. So in our scenario, our null hypothesis would be the average height is equal to 160 centimeter and the alternative hypothesis would be average height of the population is not equal to 160. So in general, if any new thing is to be proposed, it is defined in alternative hypothesis. The way to denote the null hypothesis and alternative hypothesis is H subscript 0 would be our null hypothesis and alternative would have a subscript of A. So H naught or HA. Similarly, let's consider another example. The scientists wanted to confirm the results of the research. Based on their research, they have developed a procedure to grow a fish more than what is expected in the natural environment. To confirm their theory, they needed to devise a hypothesis. So their statement is their fish grows more than 2 inches, which is more than the normal natural growth of the fish. So for this particular experiment, their hypothesis would be, again would have two parts. One is null hypothesis and second is alternative hypothesis. The null hypothesis would say that the length of the fish is less than equal to 2 and the alternative hypothesis would say the length of the fish is greater than 2, which is this part. Now if we consider both the scenarios here, the previous example and the new example, the null hypothesis and the alternative hypothesis are mutually exclusive, meaning there would not be any overlapping in them. In the fish farm example, the scientists won't be interested on proving the length of the fish is less than equal to 2. Reason their entire research work was to prove they are able to get more width or better growth in the fish over the period of 1 month or the time which they have taken. So for their or in this particular scenario, they won't be actually interested on proving they have actually performed less than. So what they would do is they would omit the less than sign from their null hypothesis. And also, just to cover the things, if they are able to prove that based on their process the length of the fish is more than 2 centimeter, then automatically they have rejected the null hypothesis, and even if they have considered as equal to 2, they are still able to prove that the less than 2 is also cancelled or rejected. So that's how people define their null hypothesis or alternative hypothesis based on their given requirement or problem statement. Based on the few informations which we have gathered in our previous two examples, the statistical hypothesis can be defined in two sets. The first set is two-tailed hypothesis testing. In this kind of hypothesis testing, our null hypothesis and the alternative hypothesis just state equal to or not equal to. It does not talk about the any direction of the data at any means, and hence it's called two-tailed. It can be either less than or it can be either greater than. If I reject the null hypothesis, meaning the mean or the, as in our example, the mean height is 163 centimeter, then but I don't know whether it has reduced or whether it has increased. And in our second example, that is one-tailed test, the reason we were very specific about the direction of the data. We wanted, or the scientists wanted to prove their process has got more than 2 centimeter from the natural growth. And that's how these two kind of tests are done or defined. Two-tailed hypothesis, one-tailed hypothesis. There is one more point which has to be taken care is while describing the output of the results. So if the null hypothesis is rejected and therefore alternative hypothesis is accepted, it is said as a statistically significant result has been obtained. In simpler words, the result obtained is not just luck by chance and the decision has been made to reject the null hypothesis. In our second example, let's say the 2.1 centimeter length is statistically significant higher than the 2. But for business, that might not be the actual significant as a result. So caution has to be taken during interpreting the outcomes of the statistical tests. The outcome of the test depends on the sample in consideration. Also, whether a slight change is substantive outcome or not would be completely depending on the use case of the research. One more point has to be considered while communicating the results of the hypothesis testing. If we fail to reject the null hypothesis, meaning our alternative hypothesis was not correct, at this particular point we just simply say we failed to reject the null hypothesis. But let's say we found a significant evidence where we can reject the null hypothesis. We does not state that we accept the alternative hypothesis. We actually say or communicate that we fail to reject the null hypothesis. So we do not mention anything about the alternative hypothesis. We just simply say we fail to reject the or we reject the null hypothesis. Steps of performing test. So there are certain steps which has to be followed for hypothesis testing. First is create the hypothesis, which is defining the null hypothesis and the alternative hypothesis. Second point, choose the appropriate statistical test, either Z test or T test or any other test. Then third is set alpha or type 1 error of the experiment. We will come to this point in next topic. Step 4, get the data and sample. Step 5, analyze the test which has been decided on step 2. And then finally communicate the decision, what has been taken based on the steps. To understand the alpha, we have to understand type 1 or type 2 errors. A type 1 error is committed by rejecting a true null hypothesis. A type 2 error is committed when a business researcher fails to reject a false null hypothesis. So type 1 error is denoted as alpha and type 2 error is denoted as beta. Alpha can only be committed when the null hypothesis is rejected, and beta can only be committed when null hypothesis is not rejected. A business researcher cannot commit both type of errors like type 1 error and type 2 error at the same time on the same hypothesis testing. Alpha is always decided before starting the experiment, where we say what is the expected false or error we can accept for the particular experiment, and that's how alpha is decided. And beta occurs only when the null hypothesis is not true. The computation of the beta varies with the many possible alternative parameters that might occur. To keep the understanding intact for type 1 and type 2 error, there is a very simple confusion matrix. So this kind of matrix are always called as confusion matrix, and they help us on easing out the confusion. So we have to take the scenarios like we fail to reject the null hypothesis and actually we made the true call. Then we have done the correct decision, taken the correct decision. And if we fail to reject the null hypothesis, ideally we should have failed to reject the null hypothesis, but we didn't, then we made the type 2 error. Similarly, if we actually should have rejected the null hypothesis, but we didn't, then we made the type 1 error, that is our alpha, and this is what we said in the beginning. And then we had to reject the null hypothesis, but we did reject the null hypothesis, meaning correct decision, and that is called the power of the statistics test, and that is calculated as 1 minus beta. Let's take some examples to understand the concepts. In this example, I have taken a height data set where the height of the people are there, and we will do the hypothesis testing. So we will form the hypothesis testing. So let's consider this entire data as our population, and let's figure out what is the average height of the population. So we came to know 168.3 is the actual average height of the given population. Now, as we know the actual mean of the population, or we can calculate the parameters of the population, hence when the population parameter is known, we have to opt for z-score method. So I am choosing the z-score method. Now we have to define our null hypothesis. The step 1 of creating the statistical hypothesis testing is create the hypothesis testing. So in our scenario, let's assume we want to confirm whether the average height is now 170 or not. So based on our new experiment, we have to define our null hypothesis as 170, and similarly our alternative hypothesis would become not equal to 170. So mean of the population is not equal to 170, and our null hypothesis is mean of the population is equal to 170. Then second is select the appropriate statistical test. As we already discussed, we know the population parameters. We will choose the z-score. Let's set the alpha as 0.05, that is our type 1 error, and as always alpha has to be set before the experiment start. Get the data, analyze. Now I have to get some sample data. For selecting the sample data, I have just written a simple code using the numpy function, and I got the information. To do the analysis, I also need the critical z-score, and for the given analysis, we also need the critical z-score. So how to calculate the z-score is very simple. We have to, at alpha is 0.05 and our experiment is two-sided. Hence we have to look into so our experiment has to be two-sided. So we will divide alpha by 2, which is 0.05. Once we know these alpha is 0.05, we'll go to z table, and here we have to check the probability. So 0.025, 1 minus 0.025, which would bring 0.9725, 0.9750, which is this place. So from here I have to look at my z and then the next decimal value, meaning it gives me 1.96 as my critical z value. So I have all the information which is required to me. Now for the particular calculation, I need to calculate the standard deviation and mean of the population. So I already know what is my hypothesis. My hypothesis is 170, and then standard deviation of the population. So that's how. So I have calculated all the information. Now I just simply put it into the formula and I get minus 2.45. Now to communicate the decision, we have to look into the distribution plot. So once we have our distribution plotted here, so this is our mean value and this is where our critical value is being defined. So our current critical value is 1.96 and the result which we have got is minus 2.4. Minus 2.4 would fall in the rejection region. Hence we would reject the null hypothesis. If our observed z value which we calculated here would have came more than 1.96 in the negative side, then we would have failed to reject the null hypothesis. So based on the current information right now, our value minus 2.45 is less than 1.96, so we reject the null hypothesis. It also, if we would get plus 2.46 is greater than 1.96, we would have rejected the null hypothesis. So our observed z score is 2.45 and our critical value calculated was 1.96. So this is how we take decision when the population parameters are known. So right now what we concluded was that we rejected the null hypothesis, meaning our mu is not equal to 170. So what did we actually did? We rejected the null hypothesis when actually it has to be rejected. So we didn't make a type 1 error, and as we know 168.3 was our actual mean. Another way to reach a statistical conclusion in hypothesis testing is by using the p-value. The p-value defines the smallest probability for which the null hypothesis can be rejected. To understand it, let's take an example. Let's set the alpha value as 0.05. Now, any experiment we will do, we will be able to calculate a p-value, and based on that p-value, we can check the p-value with our alpha level, and then we can conclude any decision based on our experiments. So let's say if p-value is less than equal to 0.05, meaning we got the strong evidence against the null hypothesis, and hence we can reject the null hypothesis. If p-value which we will get is greater than 0.05, set alpha which we have before the experiment, then if p-value is greater than 0.05, a weak evidence against the null hypothesis has been found, and hence we will fail to reject the null hypothesis. And if p-value is near to 0.05 or the set alpha, then we won't be sure enough how to take the decision, and hence in these scenarios we must pass on the p-value so that the end person can conclude on his own information. Let's do an exercise on our previous example by using p-value information. Let's say what we found earlier was the z observed value was near to 2.46. So let's take 2.45. For 2.45, if I check the value 2.45, 0.99286 probability. So at the given probability value, my p-value would be 1 minus 0.994. That comes as 0.006. So this is the p-value which we have got. Now if I check the particular value with my alpha value, if I compare it, so my 0.006 is less than 0.05. So if I check here again, we have to reject the null hypothesis, which we did. Also, let's say if my calculated p-value is 0.006 and if I set my alpha at 0.001, then I would be fail to reject the null hypothesis because my calculated p-value is now greater than the set alpha. So just to conclude again, if my p-value is greater than alpha, I will fail to reject the null hypothesis. If my p-value is less than set alpha, then I will reject the null hypothesis. Let's consider the another type of test that is t-test. And t-tests are employed when we don't know the parameters of the population. So if I have to do the t-test using the Python, there is a particular module that is called scipy.stats. So I will just simply call it, and in scipy.stats I get a particular function that is t-test one-sided sample, and if I just simply pass, so what are the parameters it takes? It takes the population mean for which we want to test the hypothesis, and it takes the particular array of the sample data. If I just simply execute it, I get to see my p-value is 0.02. So my default alpha set in the application is 0.05. So 0.05 is greater than the p-value which we have got through the application. So in this scenario, we would reject the null hypothesis, which we have done in our z test as well. Is less than true, we reject the null hypothesis. Similarly, if I test the same experiment with the new or the actual mean of the population, that is 168, and if I do the calculation I get 0.49, which is much higher than 0.05, and now we fail to reject the null hypothesis. Similarly, if I do the experiment with 169 as my mean value, and if I execute, I get 0.0 and 0.14, which is again higher than 0.05. We reject the null hypothesis. So I would suggest, please take your time and do some more experiments on your own, and do it iteratively so that you are able to understand the concept of the p-value and how to take calls based on the rejection and non-rejection reasons if the p-value is not in the consideration. I hope you understood the hypothesis testing. We would cover the hypothesis testing with 2 samples in the next video. If you like the contents, please consider subscribing to my channel and like this video as well. Have a great day.